In this video, we will show how to calculate trigonometric integrals using the substitution method. Given a trigonometric integral of the form sine of x to the power m times cosine of x to the power n dx, where m and n are integers greater or equal than 0, we can use the substitution method for integration the following way. If m is odd, we can use the substitution h of x is cosine of x. If n is odd, we can use the substitution h of x is sine of x. If n and m are even, we can use the substitution h of x is 2 times x. Notice that if m and n are both odd, we can choose either h of x equals cosine of x or h of x equals sine of x. To use these substitutions, we sometimes need to rewrite the trigonometric integral using the following trigonometric rules. Sine of x squared plus cosine of x squared equals 1. Cosine of x squared equals the cosine of 2 times x plus 1 over 2. And finally, sine of x squared equals 1 minus the cosine of 2 times x over 2. Let's look at an example to make it less abstract. We can use the step-by-step plan for substitution to calculate a trigonometric integral. Let's take as an example the integral of cosine of x to the power of 3 times sine of x to the power of 2. We first need to determine m and n to choose the substitution h of x. In our case, we see that m is 2 and n is 3, so n is odd. Therefore, we choose the substitution h of x equal to sine of x. In step 2, we rewrite the integral in a form in which we can use the substitution method. We rewrite the given integral by splitting the cosine to the power of 3 to cosine squared times the cosine. Now, we rewrite the cosine squared to 1 minus the sine squared. Next, we expand the brackets, and finally we get the integral of the sine squared minus the sine to the power of 4 times the cosine dx. Next, in step 3, we rewrite h' of x dx as dh of x to get the integral of g of h of x dh of x. Therefore, we get the integral of sine of x squared minus the sine of x to the power of 4 d sine of x. Now, in step 4, we substitute h of x equals u. In this case, u is sine of x. Therefore, we find the integral of u squared minus u to the power of 4 du. Finally, in step 5, we can calculate the integral. We find that the integral of u squared minus u to the power of 4 is equal to u to the power of 3 over 3 minus u to the power of 5 over 5 plus c. In our last step, we substitute u as h of x back into the answer. We obtain sine of x to the power of 3 over 3 minus sine of x to the power of 5 over 5 plus c as final answer. This concludes the example. Thanks for watching.